Back to the DataStudio program on the computer. We select Create Experiment, creating the experiment from scratch. If we do this, the interface should come up, our Science Workshop 750 interface in this case. If I click on the digital inputs, one of the digital inputs, I can select the rotary motion sensor and add that. We're not interested in the rotation, we're interested in the position instead. And if we select this, we want to have a higher resolution, 1430 divisions per rotation. And the linear scale we select other, it's not pre-programmed, and it is 1 millimeter per revolution. Okay, that was the setup of the rotary sensor. We can set up the force sensor by clicking on an analog input, force sensor, select the force sensor, and we will just add the sampling rate. This adds the increases the sampling rate of both measurements to 50 Hertz, which is okay. We can start, if everything works, by looking at monitor data. First of all, we should check the force sensor, pulling this to digits. It shows a value even when there is no pressure at all on the sensor head. So I press the tear button and it becomes 0. Yeah, we can remove this. We can now also check the position that it's 0, and if I turn this the right way, its value increases, so that's correct. If it's not, we can just change the connectors. We stop this. On the experiment, we want to set the sampling options. We want a delayed start based on the data measurement of the force. And only when the force is larger than half a Newton or something, it should start collecting the data. We also want an automatic stop. The force sensor doesn't take more than 50 newtons, and if I now write 50 here, it will stop automatically. Measurements will stop automatically when the force is larger. We want a graph of force as a function of not of time, but of position, and we do that by first dragging force to the graph thing, and then position, we drag that to the x-axis in that graph, so that only the graph, the axis portion is selected. Release it, and now we have the force in newtons as a function of position. The scale is in meters. We can drag this out so that we get, let's say, millimeters or something. These are still values that are too large. Okay, if we now press here start the measurements, nothing should happen except that the measurement is armed, that the delayed start is armed and turns yellow. If I now crank the arm, it should start measuring when I turn it, and I'm turning and turning until the force is larger than 50 newtons, and then it stops. So that was the first measurement, a calibration measurement. We can check this a bit and see if it's adjust the scale. We could also put this more automatic, I think. So set the scale to fit. Yeah. Oh, that was not really. A hand. Anyway, we'll do another measurement to see if this is a bit reproducible. Start. After, of course, I released the whole thing and that the arm was, yes, this seems quite reproducible. I'll just, to be sure, we will do another one. Start and turn it. That didn't go as well. What happened there? Probably the contact was a bit too late. Let's select run number 2. We can no, we want to run number 2, and if I right click that, I can change this to calibration. Enter and rename all data yes.